Yeah, good morning, guys. In the last lecture, we have seen about the arithmetic operators, but we have other operators in Python: assignment operators, comparison operators, logical operators, identity operators, membership operators, and bitwise operators. After which, we'll see the precedence of operators. That means which operators are given the highest priority and which operators are given the comparatively less priority. That is what we are going to discuss in this Python lecture. So we'll get back to our assignment operators since arithmetic operators were covered in the last lecture. You can go back to the uh, Python 0 to hero playlist over there, and you can find the content over there. So now we'll see about assignment operators. What are assignment operators? So typically we know that, see, this is operator precedence, which we'll discuss later. So typically, assignment operators, we have already encountered one assignment operators, that is direct assignment operators, x equal to 3. So this is one sort of assignment operator, right? So the value of the numeric value of 3 is being assigned to variable x. So this is assignment operators. And one more type of assignment is like x plus or minus plus or equal to 3. Okay, this sort of assignment, okay, is similar to x equal to x plus 3. Okay, what it means is this is the shortcut form of the one on the right side. Okay, this is shortcut. Okay, this is the shortcut form. So instead of writing it in this lengthy way, you can assign it in this manner: x plus equal to 3, which is equivalent to x equal to x plus 3. The same thing applies for multiplication, division, floor division, all the arithmetic operators. Okay, and also the bitwise or bitwise operators also, and not logical operators also. These things can apply. So we'll see how to have the assignment operator, how the assignment operator works, like two or three examples using Colab. So I have opened the Colab. So simply I was assigning x value to be 5. This is assigning 5 to x. The value of 5 is assigned to x. So I have to run the cell. Okay. So now what I'll do is I will have x equal to x plus x equal to x plus 5. Okay. So I'll have this cell running. So what this will do is the value of x is already 5. Okay, that 5 it is going to add with another 5. Let us suppose this is to be 7. Okay, and I'll run this again. The value of x is already 5. So always remember, assignment operator, okay, always performs the right side of the equal to sign first, and then the value of the right side will be stored in the left hand side, whichever is there, that is variable. So initially right hand side will be evaluated. So what happens is the value of 5 gets transferred to here, and 5 plus 7 is 12. That will again get transferred to x. Okay, that is how it works. So if I print now, print of x, now you'll get 12 over here. Yeah, it's it has been sorry about that. So it has been earlier I have run it again now. So that value it is storing. So now you can see it is 12. Okay. Earlier I have run it with x plus 5. Okay. Again I have run it with x plus 7. So it's adding everything. So I what I have done is I was again running this code, the first cell, and then this is the problem with cell by cell execution of code. Okay. So suppose if I run this again and then print x, it will become 19. See this. Okay. So in order to avoid that, so you have to run from the top. Okay. To run from the top. Okay. 12. Fine. So what I will do is shortcut assignment will check. So I will write all the code only here. So again I will assign x value to be 5. We'll take another variable. Okay, x equal to 5, y equal to 5. Okay, and then y plus equal to 7. If I print y, the same thing happens. This is nothing but y equal to y plus 7. Okay, y plus equal to 7 is y equal to y plus 7. So if I print this, you will get 12. Okay, so this is shorthand notation of writing it. Okay, whereas this is the long form, like expand, like the real, like whatever we do outside, like. So all the programmers, as a programmers, we have to make sure that our code is as small as possible. So definitely for assigning, or we can use this one, assigning and adding at the same time. So we can do it same for the multiplication as well. Okay. So if I just replace this operator, okay, it will become 35. It will become 35. Okay. So if I replace it with this one, divided by 5 by 7 is like it will come under decimals, some decimals, decimal points. Okay. And floor division, so 0.71. So in floor division it will remove the decimal part, so you'll get end up with only the numerical part, I mean like the real part, 0 whole number part only you will be having, decimal will not be having in the floor division. And you can also have like that is 5 power 7. Okay, y equal to y power 7. Okay, so 5 power 7 you will get. You can do manually here also, 5 star star 7, and check to see the result will be the same. So in that manner you can have the assignment operators. Then what we have after assignment operators is comparison operators. So comparison operators are like classified into, they are like double equal to. Okay, so this implies equal, and then you have not equal to. Okay, not equal, and then you have greater than, and then you have less than. Okay, and then you have greater than or equal to, all of them whichever are present in the general maths are present here. Greater than or equal to, greater than or equal to, then you have less than or equal to, less than or equal to. So you can keep them in comments. Okay, or you can keep it in doc string. Okay, whichever way you want. So doc string is like it will be having 3. Okay, and you can keep it 3 here. So this code will be treated as a just a documentation. Okay, either you can hash it or you can keep in doc string. Okay, this is called doc string. Okay, three single quotes here. So this will be for just to read whenever you understand. Okay, whenever you read, you need to understand, right? So you can write the notes, or like suppose you want to give something to someone, you are giving the code, so that person might not understand the code. Okay, so you can then have a doc string over here and explain over there what the code actually does. Okay, so that is the main purpose of doc string. So with the doc string, all the red marks or errors whichever are present are gone actually. So these are the operators, logical operators. No, these are comparison operators. So they are used to compare two values and return true value. Return true if the condition is satisfied. Okay. Suppose like I want to, so comparison operators. So you can see which is greater, which is what you can say, which is not equal to, which is less than. So this is comparing. Okay, you can run this and you can see that nothing will happen here. Okay, just that string is actually printed. So now you can actually have print of, suppose I want to print of 5 greater than 4. So this is true, so it will return true. It will return true. Okay, so if I keep it in string, then it will print 5 greater than 2. Okay, remember that. Okay, if you take away the string, then they are numbers. So then comparison operator, take comparison operator comes into the picture. Okay, if you keep it in string as it is, it will print. If you do not keep it in string, if they are numbers, then this comparison operator is going to take the place, and then it is going to compare the value of 5 with 4, and it returns true if it is, if 5 is greater than, and you can see that 5 less than 4, it will be false. 5 not equal to, okay, 5 is not equal to 4, right? So true, this will be true. It's still running. Yeah, it is true. And 5, these are the operators. You can have greater than or equal to, so it will compare both the things. So this is also true, right? It is greater than but not equal to. So you can have a various combination of that. Then you have logical operators. Okay, so logical operators are, if you want to combine two things and check two conditions, then you have a logical operator. Requirement of logical operators, they're basically conjunctions. Okay, in English. Okay, suppose mm, like and statement and or statement. Okay, so and means the first condition and second condition both should be equal. So I will have logical operators over here. Logical operators. Okay, there are two logical operators which I will keep in docstring. One is and. Python supports two logical operators and. Okay, majorly two are used. There are actually uh, three operators, but and or are actually widely used, and not. Okay, so these are the things: and or and not, and or not, three things. So what this logical operators will do, and no, they'll connect to two statements basically. So two statements for and, both the statements should be true, valid. Then it will return true. Okay. Or means A or B means either A should be true or B should be true. Either of them can be true. That implies entire statement is true. Okay. So logical operators will have two statements. Okay. And the two statements are connected by, okay, and or. Okay. And if it is connected by and, two statements should be true. Then only it will return true. Okay. If any one statement is false, then it will return false. Or operator, what happens is, in two statements, if one statement is true, that is enough for it to become true. Okay. So I will have an example for that. Suppose that print of, okay, 5 greater than 4 and, okay, 4 greater than 10. So what it will return? See here, there are two statements here. First statement is 5 greater than 4. The second statement is 4 greater than 10. This one is true because 5 is greater than 4. This one is false. Okay. So this one is true, this one is false. Okay. And means both should be true, then only it will return true. Otherwise it will return false. See here, this is going to return false. And here if you keep less than, okay, this is becoming true. 5 is greater than 2, 5 is greater than 4, and 4 is less than 10. So now it will become true. Excellent. So that is fine. So earlier we have seen that if uh, 4 is greater than 10, it is pointing out to be false, right? But if you replace the operator, any of the things are true, like 5 is greater than 4 is true, and 4 is greater than 10 is false. So this is true, right? Hence the entire thing is true. Excellent. Okay. So now what we'll do here is, we will have a discussion of not. So it will actually reverse the result actually. Suppose I want to have reverse result. Okay. I want to make this to be opposite of what we actually got. Then you apply not operator. Okay. Then actual result will be inverted. Okay. True and false are boolean values, remember that. So now you'll get false. Okay, you'll reverse the result. That is the, so I'm control getting. So I'll have one thing that is like, both are false for R, and we will wind up the logical operators. Okay. So 4 greater than 5 or 6 greater than 10, both are false statements. Okay, and you have R, then the answer will also be false. If either one of them is true, then you will get true. Okay. So next one, identity operators. Okay. Identity operators. So identity operators, Python identity operators. Okay. hash, comment it. Okay, you add hash at the start, it becomes a comment in Python. Okay, so now what are the operators that are present? Is, comma, is not. Okay, these are the identity operators. So what does it mean actually? So you just print the documentation. Okay, so what does it mean? Suppose I have x equal to, okay, 4 5 6. Okay, and I have y equal to 4 5 and 6. Okay, both are same. Suppose I print x equal to y. What happens? It will return true. Okay, because both are equal, it will return true. Okay, but if I add x is y, okay, then it will give false. What is the reason? Because Python considers both to be different objects, because they are defined with different variable. Okay, and if I assign z equal to x, okay, now because the value of x has been transferred to z, that is there in the syntax. Now if I print x is z, then it will return true. See here. Okay, see, and y is not z, right? So y is not z. Okay, then it will return false, true, sorry about that. Okay, because y value is not being assigned, y is not assigned from x. Okay, it is an entirely different object, it will have different memory locations. Okay, but when you assign, what happens is it shares the same memory location. Okay, I mean, when you assign variable value, the value of variable inside x into z, what will happen is they share the same memory location. Those are identity objects, identity operators. So the main function is, okay, they are used to compare the objects, not if they are equal, but if they are actually the same object. Okay, they are actually the same object a card. So if they are same object or not, that will be decided by them. Okay, now what is membership operators? This is about identity operators. So then what is membership operators? These operators are very important because they form the core of programming for any language. Okay, you need to understand and have a good overview of all the operators in Python in order to have a good grip of the programming with respect to Python. So next one, Python membership operators. So in and comma not in. Good. Then what we'll try to do is returns true if the value is in the list. Okay, returns false if it is not in that particular list. Suppose I have a list x equal to 4 comma 5 comma 6. List and all we'll see again. Okay, print of, okay, 4 in x. Okay, what it prints is, it will check for the value 4 if it is present in list x. If it is present, then it will return true, otherwise it will return false. See, this one should return true. Okay, so if 4 in x, it will return. Now I'll check for 10. 10 is not in list, so it will return false. So not in is exactly the opposite of in. These are membership operators. So they are basically used to check whether a particular element is present in a data type or not. Okay, and I think this can not also be a tuple. We'll see what is tuple, what is list. Okay. Yeah, this is also can be true, like this also can be valid for set as well. Okay, you change the type of the brackets, change the type of the data set. Okay, data type actually. Okay, square brackets, it is called list. Curly brackets, it is called set. And round brackets or small brackets, whichever you may call, is tuple, which we'll see again. Okay, so these are actually used to membership operators are whether they are used to check whether that particular element is a member of that particular list or set or dictionary or whatever it is. Okay, that is what. And next one is Python bitwise operators. So Python bitwise operators. So although nowadays bitwise operators are actually very rarely used in programming languages, earlier days, whenever like uh, using microcontrollers and microprocessors, okay, we need to have some programs earlier. So to have a addition, we need like left shift, right shift operator. Okay, so left shift of a digit is nothing but bitwise. Left shift is nothing but multiplication. Multiplication with the 2 actually, if it's a base 2 number. And right shift operators is nothing but it's division actually. Okay, you can see that. Okay, suppose I have 3. Okay, I am right shifting 3. I am left shifting 3. Okay, that means you add 0, append 0. What it is becoming 30. This is a base 10 number. So what is happening? Multiplying with the 10. Similarly, okay, left shift of a bitwise operator, what it essentially indicates is you are actually multiplying the number with the 2. Okay, so bitwise operators we'll see. So like yeah, this is bitwise and bitwise and then what else we have? Okay, we have 3 quotes such that it will be a doc string, otherwise it will show error. Now we have bitwise or. So bitwise or is like a pipe. Okay, pipe symbol in between. So that is this one. This is hyphen. Remember that this is not a symbol. Okay, this is hyphen. This is actually the symbol I am placing here. So this is bitwise or. Then you have XOR symbol. It is cap. It is confused with power. In Python, power is 2 stars. Remember that. Okay, this is bitwise XOR. Bitwise XOR, and you have negation symbol. Okay, a negation is bitwise not, so it will invert all the bits. Okay, invert all the bits. Bitwise not. So you have a not operator in logical also, that is completely different. This operates only on numbers. Bitwise operators operate only on numbers. Okay, logical operators can operate on numbers as well as strings, whatnot. This operates on bits only. Bits means base two numbers only it will operate. Okay, if it is a base 10, like decimal system, it will convert into bits, and then it will convert into what you can say, base 2 number, and then it will actually do the thing. Okay, bitwise not. And then you have, these are very important, left shift, zero fill left shift. Okay, that means, and then you have right shift, signed right shift. And then, yeah, these are the majorly used things, which bitwise and bitwise or. Okay, I will explain in detail how these things work. Okay, uh, so I'll take paint. So suppose you have a number, like you have a number, I want to have 5 bitwise operator with 7. So what is the like like binary representation of 5? I think it is 101, right? Actually, to be precise, it is 0101. And then you have, for 7 it is 0311. Okay, yeah, and you have to do the logical AND operator, logic bitwise AND operator. So if you perform bitwise AND operation, what will happen? What will happen is, bitwise AND means it will return 1 only when numbers or the places in both the digits, both the numbers are 1, then only it is going to return 1. Otherwise it will return, if any one of the digit is 0, it will return 0. Okay, that means here, here, okay, these two are 1 and 1, so it will return 1. These two here 0 and 1, so it will return 0. And here again 1 and 1, it will return 1. So the answer would be, so 0, 1 1 is 1, 0 1 is 0, and 1 1 is 1. 0 1 0 1, which is 5 again. See, so if you do the logical and if you do the bitwise and, you should get between 5 and 7, you should end up getting the answer to be 5. Let us check it out. So this is 5, right? Okay, this is a decimal representation of the binary representation, and corresponding decimal equivalent is 5. How do you convert it? Okay, this last digit will be multiplied by 2 power 0, last but one will be multiplied by 2 power 1, and this one will be 2 power 2. Okay, so it has ones at 2 power 2 position and 2 power 0 position. So 2 power 2 into 1 and 2 power 0 into 1, which will give you the 5 as the output. So you can test it out actually. Okay, yeah, print of 5 bitwise and with 7. You should get 5. Yeah, you're getting 5, right? Excellent. So now what we'll do is we'll have a logical OR operator, logical OR 7, and then we'll have the same thing. 0 1 0 is 5 and 7 is 0 triple 1, right? So what would be the answer here? Yeah, here also you can see that for OR operator, bitwise OR operator, it is going to return 0 when both are 0. Okay. The rest of the cases, any one of them, if any one of them digits in two numbers is 1 at their respective positions, then it will return 1. If both are 0 only, it will return 0. Okay. Any one digit is 0, any one digit is 1, it will return 1. Okay. So here both are zeros. So what it will return is 0. 1 and 1, it will return 1. 0 and 1. So if at least 1 is present, then it will return 1. 1 and 1, 1. So this is equivalent of 7. This is equivalent of 7. You can check it out actually in Google Colab as well. Print of 5 5 7. So you can see it will be having 7 here. Now we'll see about XOR. So XOR operator. So XOR operator. So 5 5 cap 7. So XOR operator. Same thing, 0 1 0 1 0 1 1 1. So what is XOR? So XOR is like if both are zeros or both are ones, okay, both are zeros or both are ones, then it will return 0. If one is 1, if any of the digits is 1, it will return 1. Okay. So both are zeros, it will return 0. Both are ones, it will return 0. Okay. And both are here in this position, you can see one of the digit in the first number is 0 and in the second number is 1. So it will return 1, and the last one both are zeros. So this is like the answer should be 2 XOR. Let us see the XOR. Don't get confused with cap as power. Okay, in calculators we see that cap is taken as power, but in Python cap is XOR operator. So you should get to see this. You're getting 2, right? Next, so is left shift and right shift operator. Okay, so left shift and right shift operators. So it is like double less than sign. So now I just want to remove all these things. Okay, I'll just select. Okay, shift operators. These are very important. Yeah, I'll select it to be some bigger font. So left shift operator, left shift bitwise operator. Suppose I have given, okay, bitwise operator. Yeah, suppose that I have given 5, okay, is to 2. So it will shift by 2. So what will happen is, mean, if you don't give anything, okay, like in this left shift operator, what the left most part of this symbol left shift operator, okay, indicates is, okay, how many, okay, what is the number that on which the operation has to be performed, and right side of this left shift operator, whatever the number is there, it determines, okay, how many times the operation has to be performed. Okay, so you have to left shift 5, okay, binary value of 5 2 times. Okay, so first of all let me write the binary form of 5. It is 0101. Okay, so what I'll do is I'll just left shift it. Okay, left shift. Okay, so 5 left shift. So first time left shifting, what will happen? It will become 101, and you have to impend the right side with 0. Okay, so this 101 is left shifted, so 1 is left shifted. Okay, so this is the value of, okay, if you take the decimal value and check it out, so this one, the first digit's weight is 8, okay, and this one weight is 2, second one weight is 2. So first left shift, okay, so what will happen, becomes 10. Second left shift, what will happen, so this one will go to 001. Okay, another 4 blocks I am taking, and then you have 0, okay, 100, okay, sorry, 0. So this one has gone to another place. Okay, the one got shifted again. Okay, I'm separating 4 digits. So this is 1010 actually, and at the end you have added another 0. Okay, two zeros have been added for the first time. Okay, first shift 10 was added. Second shift we are impending with zeros at the last. Okay, after left shift, these places will be empty, right? So we are adding the adding the zeros. So the original number here is, the original number here is 5 has been shifted. So this one, right, 0101 is the original number. 0101 is the original number. It has been shifted by impending zeros. Okay, so first case you've been impended 0 here. Okay, and second case again you have been impended with zeros again. So what is the value of this? Okay, the value of this will be, this place it is 16 and this place it is 4. Okay, you can check it out and you can see that 20. Okay, so what is happening is, if you shift left by one time, you can see the number is doubled, multiplied, sorry about that, multiplied by 2. It's not doubled. Yeah, you can say this doubled. Okay, because multiplication with 2 is doubled only. Okay, multiplied. On a general notation, you can say left shift operator bitwise, what will it do is, it will multiplied by 2 or base. Okay, okay, base is 2, right? 2. So you shifted one time, it got multiplied, it got 5 into 2 is 10, and you shifted the second time, 10 into 2 became 20. So the same thing, put here, print of 5. Okay, shift operator 2, you can see it becomes 20. Okay, if you put here 3, it becomes 40. Okay, so that is bitwise operator. And the most important thing, and again, you are impending right side with 0, remember that, padding the last ones with zeros, remember that. And then what else you have, right shift bitwise operator. Okay, so it is 5. We'll take a bigger number, let us say, yeah, we'll take 20 only, or we'll take, yeah, 20 will take, because we have the binary of 20 here. So it is 0 0 0 0 0 1 0 1 0 0, which I have taken here itself. So if so now what I'll do is, I'll perform 20 followed by right shift 2. Okay, which should actually return me 5. Okay, so if I right shift, what will happen, so this will come here, becomes, and we have to remove the zeros. Okay, so we are right shifting here, 0 0 0 0. Okay, this one will right shift now, this will come here, 1 0 1 0 1 0, and the right side, this 0 should be discarded, should be discarded. So this discarded, and you have to pad the extra 0 here. Okay, this is the equivalent of 10. Okay, and if you once again shift, it will become 0 1 0 1, which is equivalent of 5. So it is like left right shift operator is dividing by 2, dividing by, dividing by 2, dividing by 2. So we'll have the same thing over here. print of 5, no, it's 20, right? Print of 20 greater than, I mean, like right shift operator, and you are shifting it two times. So you'll get 5. Good. If you shift one time, you will get 10. Okay. 20 by 2 is 10, right? And 20, if it is shifted two times, it becomes 5. Okay. So that is fine and that is good. So this is the right shift operation. So shifting right side means it is a division operation. Shifting left side means it is a multiplication operation indirectly. If you shift by 3 times, what will happen? Again 5 divided by 2. Okay, 5 divided by 2 is 2.5, but I think if you I think it will give us the result to be 2. Yeah, no decimals involved. Okay, so this is how the bitwise operators work. We have covered all the operators. The previous lecture we have covered arithmetic operators. In this lecture we have covered assignment operators, comparison operators, logical operators, as identity operators, membership operators, as well as bitwise operators. Okay. Yeah, my mouse got stuck somehow. Yeah. Okay. Here we go. So we have covered all these things. Now we'll see precedence. What is precedence? So this is the precedence. So first of all, whatever is the parenthesis has the highest precedence. Okay, parenthesis has the highest precedence, whereas exponential has the second next, and then you have unary operator like the I mean it determines whether the number is a positive or negative, and bitwise not is having the third highest priority. Then comes the arithmetic operators. Okay, this is having the fourth priority. Okay, and then you have addition and subtraction. Then you have bitwise left and right shifts, bitwise and bitwise XOR. Okay, suppose you have something like this. Okay, so this is the precedence. Okay, you have multiple operators in a statement in a code. Then how to deal with that? How to expect the result? Okay, suppose you have something like this. Okay, so 5 plus 2, okay, star 3 minus 1. Okay, then you have brackets. Okay, you have brackets. So what will happen? So operator precedence. Okay, first is for parenthesis. So parenthesis, whichever is there in the parenthesis, first it will be executed. So entire statement is in the parenthesis, so no need to worry. Then what it will check for? Okay, then the second one is exponent. As you can see from the slide, the second one is exponentation. Okay, so first it will evaluate this one. Okay, 2 power 3. So 2 power 3 is 8. So after which you have the precedence. Okay, after exponentation you have the precedence of yeah, multiplication, division. This is the order. Okay, multiplication, division, and you have addition and subtraction here after multiplication and division here. So second precedence in our statement is add. So add and subtract. So 5 plus 8 minus 1. 5 plus 8 minus 1 is 5 plus 8 is 13. 13 minus 1 is 12. So it should have the answer to be 12. Yeah. Suppose we change the parenthesis a bit, the same statement. Okay. 5 plus 2 star star. Okay. 3 minus 1. And you have entire parenthesis over here. Yeah. Showing some error. Okay. Let us have like 5 plus 2. Okay. And you have star star. Okay. 3 minus 1. Okay. So now same thing, but the answer will be first inside the parenthesis, whatever is there that will be executed. What is there inside the parenthesis? 5 plus 2 and 3 minus 1. 5 plus 2 is 7. Okay. And 3 minus 2 is 3 minus 1 is 2. Then it will evaluate. Okay, you can see first of all parenthesis. Okay, so whatever is there in the parenthesis, first of all it will evaluate. So what is there in the parenthesis? 5 plus 2, 7. Okay, here 3 minus 1, 2. 7 power 2 will be 49. The answer will be 49. Yeah, that is how precedence can affect the answer. Precedence can affect the answer. Yeah, you can have the same thing. Okay, 5 plus 2 star star. Okay, 3 minus 1. I think it's not yeah, the same thing. So now what it will be? First of all, what it should evaluate? Okay, inner parenthesis. There are two parentheses, then it will evaluate inner parenthesis. 3 minus 1 is 2. And then exponent. 2 double star 2. So it becomes 4. So it will be 9 answer. Answer should be 9. Okay, my runtime is being disconnected and sometimes it happens. Okay, I'll just runtime connection taking time, so I'll just show it. I'll just show it in online compiler. This one, right? This should be resulting in, instead of this one, I'll replace it with our thing. Okay, you can see it will be 9. See here, 9. So you have the same numbers, same operations, but differently organized parentheses and differently organized operators, then you are getting different results. Okay, this manner. So if you need to evaluate something, an expression, you need to definitely follow. You need to definitely follow the precedence, the operator precedence. Okay, it's trying to connect. Okay, I don't know why it's very slow. Okay, yeah, you can try another thing like suppose there is something like print of 6 plus 2 power 3. It's not power XOR actually. So what is the answer here? Is it 8 XOR 3, or first of all you need to perform 2 XOR 3? Okay, go to the precedence. Okay, then look for it. You can see bitwise or. Where is the bitwise or? Bitwise operators have less precedence. Okay, bitwise operators have less precedence compared to addition and subtraction. So first of all you need to do the bitwise XOR. Okay, 2 XOR 3. What will be the 2 XOR 3 value of 2 XOR 3? If you do it in paint, okay, I'll write here. The value of 2 is 0010. The value of 0 is 3 is 0011. So XOR means if there is 1 only, you'll get 1. So the value is 1 actually. Okay. So both are zeros also 0. Both are ones also 0. 1 and 1 0, it will become 1. Okay. So what we should do here? So 2 XOR 3 is 1, so it should give you 7. First of all, actually, addition should be performed. Sorry about that. Higher precedence, no. Okay, sorry about that. Bitwise operators has higher, lower precedence. Okay, so lower precedence. So this would be wrong if I call it 7. You are getting 11. Why? Because intentionally I have made you this mistake. You have, while calculating the answer, you have not taken into account the operator's precedence. So if you go here precedence, first of all what should be done? Addition and subtraction. Then only bitwise operators are following. Bitwise and, bitwise or, bitwise XOR is the last. Okay, so what you should do, this is 8 XOR 3. Now if you do that in paint, okay, this is how actually. So 8 XOR 3, 8, the value of 8 is 1000. Okay, so this is 1, this is 0 and 1 1. Okay, which is a decimal equivalent of 11. So this is 8 plus 2 plus 1. Okay, at 2 power 3 position it has 1, at 2 power 1 position it has 1, and at 2 power 0 it has 1. So if you don't apply the precedence, you will get a wrong result. Remember that. Okay, remember that. And now if you have this thing wrapped in parenthesis, okay, the XOR operation is wrapped in again inside parenthesis. Okay, now definitely 2 XOR 3 has to be performed first. Now you will get the result. Okay, the earlier result 7. See this earlier result 7. Okay, wait a second. Yeah, 1000. Yeah, we'll stop here and we'll discuss the things later on.